Welcome to Chapter 7. This is the chapter where it all really starts to pay off. We have been learning bits and pieces and doing little 2 lines, 3 lines, 4 lines of code to learn the basic building blocks of Python and learn some of the syntax and define lots of terms. But now we're actually going to start doing something. So if you look at what we've been doing so far, we're inside this little computer, and you type up, the Python says what next, and you give it its command and it does something, and you do something else and does something, and you do this 3 or 4 times, unless you write a loop, and then it goes like 10, 20 times, and that's it. And then maybe we write a thing that reads something from our keyboard, gives us something back, and then we write something that prints something out, print a few things out. And so we've been pretty much using the keyboard, the screen, the CPU, and the memory. That's kind of where we've been living. And while it's important to talk to the keyboard and the screen, the real world is things like databases that live out here, files that live on our systems, and connecting to the network and reading data from the network. And so that's what we're starting to do right now, is we're starting to be able to work outside kind of our code and create things that are permanent. And so we're going to be talking, initially we're going to work on files. We'll later talk to databases and the network and other stuff, but for now we are talking about files. And so really we're stepping out a little bit and reading things that are permanent and creating things that are permanent. The kinds of files that we're going to talk about mostly are text files, and you can think of these as a sequence of lines in a file that are easily read by Python. You've been making text files all along. Your hello.py, that file's a text file too. You're using a text editor to create that file. You put your Python commands in a file, you run those files, and that's what it is. And so a file can be thought of as a bunch of lines, 1, 2, 3, 4, 5, 6, 7, a blank line here. That's possible. And but the reality is that these are actually just lines, and we have a special character called the new line that we'll talk about in a second. So to read a file, you have to call the open function. And open returns what we call a file handle. Open doesn't actually read the file. Open makes it possible so that you can read the file. So the parameters to open are, it takes one parameter that's required, which is the name of the file. Another parameter that's optional, whether or not to read it or write it. If we're reading the file, it doesn't harm it. You can read it over and over. If you write it, if there's already data in that file, it truncates it and writes something. And we're not going to really write files, we're mostly going to read them. And so open you pass it in a file, it gives you back this file handle, and then you have a variable in which you store it. I often call it fhand to be mnemonic. You'll see my code, I use fhand all the time to indicate that that is a file handle. And so if we were to run this in interactive mode, we'll open mbox.txt, and that is a function built into Python, and then it gives us back a handle. It does not give the data. You can kind of see this when we print out the file handle using the print statement. It doesn't print the lines that are in the file. The lines that are in the file are sort of out there. There could be like 10 million lines for all we know, lines in the file. The handle's like a little opening outside of your program, and you can talk to the file by opening it. Then you can read stuff. If you're writing the file, you can write stuff, and then you close the file to shut the handle down. But handle is a thing that allows you to get to the file. It is not the file itself, and it's not the data in the file. It's just a wrapper that kind of allows you. So this, if you print it out, it's like that's the file we opened, we're reading it, and encoding has to do with the different kinds of character sets, which we talked about at the end of the last lecture, that Unicode character set, etc. UTF-8 is a great character set. It's probably the most typical character set that you will run into, although you can have different character sets of files, but most of them are UTF-8. So, of course, this is Python. If you make a mistake and there's a file that doesn't exist, we get a traceback, and it blows up. We'll show you in a second how to deal with that. Now, the new line character is an important part of file reading. And in files, in strings, we can put the new line character in by this \n character. And the \n is the character that indicates that we're supposed to go to another line. Go to a new line. Go to a new line. And so we have, what is this? Well, that's a \n. That's a \n. And so if we print it out, we print it this way, we see that the \n is in there. This is how we type it. We actually type \n to Python to indicate that we're supposed to put that there. But if we do a print statement, it actually interprets the \n, and so the \n causes kind of this movement to the beginning. Now the print actually, at the end of this, adds another \n. So the \n that we put in by putting it into the string is that one, and then print always puts a \n at the end. There's actually a way to override that \n behavior by putting something on the print statement, which we'll talk about later. Now, it's important to note that the \n is one character, right? And so even though this x\ny prints this, and then print adds another new line to go down to here, if you ask how many characters, what is the length of this? Well, it's only 3. That's because that's a character, the \n is a character, and the y is a character. So it's a 3-character string. So the \n is a character like all the rest of the characters, but it's only, we encode it by typing \n. It's called an escape, where the \ is the escape, \n is a way to say new line, because we can't see it. It's a way for us to encode in a string this non-printable character, this invisible character. The white space, it's part of white space. So as we're reading through the file, we can think of it as a sequence of lines, and we can read these a line at a time. We can also read them a character at a time if we want. And so, but it's more common to say read this line, read the next line, read the line after that, etc., etc., etc. But the way to best think about this, it doesn't really matter. You can think about it as lines, and we will in most of the programs that we write. But realize that the way when we see this, when we see it like this, it comes back to the beginning, it comes back to the beginning. There's a character in the file at each of these points to say go back to the beginning. It's like hitting the enter key on your computer. And that is a new line. So you have to think that in the file, in order for your text editor and Python and everybody to know where the lines end, you put new lines in the file. And that's another character. So, you know, this looks like an empty line. This line here looks like an empty line, but really it has a single character, and the character is a new line. And it turns out that in a bit we're going to need to keep track of the fact that every line is ended by a new line. So up next, I'm going to talk a little bit about how to read files in Python. So we're going to find that there's a number of different ways that we can read through the file, but the most common way that we're going to read through the file is to treat it as a sequence of lines, and we're going to use the determinant loop, the for loop, to do this. And so what happens here is we get back this handle that opens the file and gives us back the handle. That handle x file is the variable I named, I just named it x file. That's not the data, but it is a sequence. It is that file handle represents to Python a sequence that we can potentially walk through and then get all the lines. And it's the simplest, most beautiful, elegant way to read all the lines in a file. We use the for loop, and we have an iteration variable. This is going to take, when we talk about the file, cheese is going to be the first line, then the second line, then the third line, then the fourth line. So it's like going through a string, but you're going through a file now, and you're getting it line by line. So that's each line. I just picked a variable named cheese so you didn't get confused. Later I'll call this line, but Python doesn't know anything special by naming that variable line. Okay, and so this is, it's the for and the in, and so for, I read this as for each line in the file x, the file handle x file. So run this loop one time for every line and then print it out. So it's actually really quite simple. Okay, other languages like C or C++ or other languages, they have to write while loops with end of file conditions and all kinds of things that make this very difficult. But this is one of the prettiest things that Python has. It's a very, very pretty thing. Okay, so let's talk about what we might do. And we're going kind of back to iterations now. What if we wanted to count the number of lines in a file? Well, this is a basic loop counting pattern. So we open the file, and then like in all these loops, we do something to sort of prime the loop to get it started, set a variable count to 0, and I'm going to use the variable line that's going to go through each of the lines in the file, for line in fhand, down the file, and it's going to run this loop once for each line in the file, and the variable line is going to change. But all I'm going to do is add count equals count plus 1, and so that's just like from counters, that's just how you detect. So every time we see a line, we're just going to add 1 to the counter. We're not printing the line, we're not even looking at its data at this point. And then when the line is done, however many times it has to go, out it comes, and we print out line count equals count. And so if we open inbox.txt, this is going to do all this work and then print this line out and say line count is 132,045. So this is a little 5-line program that shows you how to count the lines in a text file using Python. Again, simple and elegant and not too much syntax for you to have to learn. Now it's also possible to read the file as a series of characters all in one go. Read the whole file in. Now you got to be careful depending on the size of the file. This is going to lead to a string variable with a lot of data in it. Now if it's 100,000 characters, that's actually kind of a small thing. But if it was 10 million lines, that would probably not be good. You'd want to read it one line at a time and process each line and then do something. But mboxshort.txt is a small little file. So we open it and we get back a file object, file handle object, and we call the read method, and that says go through and read all the text and give it back in one big blob, one big string, and I'll put it in imp. And so that's where you have a line, a new line, a line, a new line, a line, a new line. It's not really lines, it's just a sequence of characters with new lines in there to punctuate them. And now you can split that, later we'll see how to split that into separate lines if you want. Now I picked a file that was short, and so this imp variable now has a string in it, and I can use the len function, pass a string into the len function. It says, oh, 94,626 characters. That's kind of a small little file, and perfectly okay to read it all in one go. And so now I say just print the first 20 characters. That's beginning to up to but not including 20, and so it shows the first 20 characters of that little file is a from line, because this is a mailbox file. Now, let's say we're going to do a searching, and we did this loop where you're looking for something. And so we're going to search for lines that have a prefix of from. Okay, that's what we're going to do, and we're going to print those lines out. So there's lots of lines in this file. Line, 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 from. Line, 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 from, right? On and on and on. And we only want to show these lines, the ones that match, right? That's what we want to do. And so we are going to write an open statement, and then we're going to loop through, and we're going to ask the question, if the line starts with from, print it. So sometimes it's going to skip, 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 and then it's going to run it, and then skip, 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 and it's going to run it, skip, 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 and then it's going to run it. Okay, so that's the basic idea, and then it'll finish when it's all said and done. And so this is like a criteria. This is like a search. We're looking for lines that match the string, that have the string from as their prefix. Now, when we look at the output of this, it's kind of weird. We see kind of these little blank lines that show up. Blank, 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 blank. What's going on here? What's going on? So let's take a quick look. The problem is new lines. Well, I mentioned that the file has new lines in them. And so when you do the for loop, it doesn't throw the new lines away. As you might expect, it would be kind of nice if it did, but it doesn't. It actually shows you when you read, it reads that first line up to and including the new line and gives you that back as the variable. So that is the first new line, so that means it's going to go down. And then the print statement actually adds another new line. So that's the second line of the file has a new line at the end of it, and the print statement adds another new line. So if we take a look at the code, there is a new line. Oops, come back. If we take a look at the code, this variable line has a new line in it. Oops, where am I at? I'm in the wrong slide. There we go. Yeah, this is the one I want to do. If we look at the code, there's a new line in here, and then the print adds another new line. So the print adds a separate new line. And that's how we get two new lines. The print statement's new line and the new line from the file. Here's how we fix it, and you're going to write this code a lot because when you're reading text files, you end up with a new line, and often you don't want the new line. But thankfully, as we saw in the previous chapter, there is a nice little function in Python for strings called strip that allows you to throw away white space. And to review, remember white space is anything that doesn't print. And this new line is not a non-printing character. So our strip gets rid of it. So it's a way to get rid of white space. And our strip does it from the right end. So it's the right end of the string. And so if we just are going to loop through all the lines in the file, we say line equals line rstrip, and then this variable no longer has the new line at the end of it. We have our little if statement, and if we print it, then this line, the data has no thing, and then the data has no new line in it, so the print only goes down one. And so now we have single spaced output. And so you're going to be doing that a lot. It's really common to read through a file and then just strip the new line or any trailing space off the end of that. Now, there's a couple of ways to do a loop like this, and let's just think of this as we're looking for a file with lots of different lines in it, and we want to ignore all the lines except some, say, good lines, and we want to do something with those good lines, or the lines we're looking for. Needle in a haystack. This is like searching for a needle in the haystack. So if you look at this code at a high level, we're going to loop through everything, and then we're sort of picking which lines are, and these are the good lines down here. Now often we have a bunch more code that we want to do, and we're not just printing them, but we're going to do a lot of code. So sometimes you actually structure the loop a little bit differently. And so the way to do it, and this is going to do the exact same thing, it's just a little different way of thinking about this loop. So the top part is the same, we're stripping it, and what we're doing here is everything's the same here except we add this and not. If the line does not start with from, that's the translation of that. If the line does not start with from, continue. So basically we have a skipping pattern. So the lines we're not interested in, we skip. So we come down, we skip a lot of lines. And then we find a line that's good, and then we fall through. So this is the good code, and then we have all the other good code that we want to do to that line. We have that showing up down here. And so there's just two patterns, two ways to do the exact same thing. So another way to select the lines that we're interested in is to use the in operator. So we talked before about the in operator and how that works. So we're basically going to use the continue skipping method. So we're going to read all the lines, these first few lines. If uct.ac.za is not in the line, skip it. And so this is going to print out all the lines that have the string uct.ac.za in them. And so you see this is the output of the program, ... Sometimes you'll have programs that want to read different files. Often I give assignments where I say, show me how this program runs on the short file, and then show me again how it runs on the long file, just like this. And so the way we do that, to input the file name, instead of making the file name be a constant to the open call, we make the file name be an input. So we just run an input statement, which gives us a prompt, and then we type mbox.txt, and then that shows up in this variable f name. It's of course a string all the time, and we pass that into open, and then we open it, and then we do the count operation. So if we enter mbox.txt, it counts 1797 subject lines in mbox, and if we give it mbox short, it says there are 27 subject lines in mbox. And again, this is another one of those ifs, and it's just counting, but only counting lines that match a particular pattern. Okay, so now the user can also type bad file names, and we need to be able to deal with that as well. And so we're taking a small change to the code. The dangerous code is this line right here. This line right here is going to trace back if that file doesn't exist. So what do? Well, we're going to just expand that. The rest of this program is exactly the same. The only thing's different is we've got this line. We took out insurance on it, and we know that it might blow up, and so we have it in a try and except block. So here's how the code runs. So, the input runs, we type in a good file name, it comes in here. This works, and so it skips the except, and so it runs the code and prints out the count. So that's the good pattern. The bad pattern is here, where we type in a bad file name, it comes in the try except, this file name is nanaboo, and it's going to blow up, so this line blows up, so it jumps down into the except code, prints out, file cannot be opened, so it prints this out. Now this quit is really important, because if we don't put this quit in here, it's going to continue down here, and that's going to blow up here, because file handle is not defined properly at this point. And so what we have is, we have this quit is a special function where it comes in and never returns. So this is a way to terminate the entire Python program silently with no traceback. right? So we put in our own error message, so we look like we're professional, say, oh, could not open this file, and then we stop. If you don't, it's going to come down here and it's going to trace back right there. It's going to blow up. So the quit is useful when you want to stop executing because you've detected some kind of an error. So that's a quick zoom through opening and reading through files and doing some patterns. Most of the rest of the programs in this course are going to say open for rstrip, look for, and then do something interesting. That's going to be our loop that we're going to do over and over and over again. And now we see how this looping and if and iteration and variables are starting to come together, and you can actually sort of do a program that does something useful. But before we get to too many more programs, we got to switch a little bit, switch gears, and talk up next about data structures, and that is the shape of data, and how we can use more intricate and complex variables to help solve our problems. Hello, and welcome to Chapter 8. We're going to talk about lists in this chapter. Up to now, we've been talking about algorithms. Algorithms are the concept in computer science of using the programming language to express the steps that you want the computer to go through to solve the problem. Read some data, convert it to a floating point number, check to see if it's greater than 40, do one thing if it's greater than 40, do another thing if it's not, then print out the result. Or open a file, read everything. If the first line starts with something, do something. If not, skip it, and then add all the things up. Those are steps. Those are a series of steps, and hopefully by now you're getting to the point where you have a good understanding of steps. But there's a whole other side of computer programming, and we call it data structures. And data structures is not the steps, but instead clever ways that you lay out the data and clever ways that you make sure that the data does what you want it to do. And so that's what we're going to start talking about now. Lists are the first and the simplest data structure. Strings are kind of like data structures, but lists are probably our first real data structure that we're going to think about and design and make use of effectively. But before we talk about what is a collection, we should talk about what is not a collection. So we're familiar with what a variable is. We know that a variable is a little piece of memory that's got a label on it. And then an assignment statement, sticks a 2 into X, and then 2 is in this little cupboard. And then it goes to the next line, and then 4 goes into X, and so the 2 goes away and the 4 is there. Now, a key thing is you can't have more than one variable at any given moment, right? And more than one value in a variable. So when we move to collections, collections are more like suitcases. We can put lots of things in them. We have ways of organizing them, and as we go through lists and dictionaries and tuples, we'll see how there are different ways to organize them. And as a matter of fact, we've been talking about lists for a while. Every time we use one of these square bracket syntaxes in earlier programs, we've been working with lists. And so this is technically a 3-item list with 3 strings, got commas here. Joseph is one string, Glenn and Sally are another string. And here's another one that is another thing. And the list is basically, it's a list constant and it's being assigned into a variable. So this friends variable has 3 things in it. So that's different than what we've been talking about before. So these bracket structures with square brackets are those lists. And so the print is just a print with parentheses to get the print to work. But 12476 is a 3-item integer list. Red, yellow, and blue is a 3-item string list. But it doesn't all have to be integers or strings. Python can handle different things and different kinds of data in different positions in the list. So red, 2498.6, a 3-item list with a string, an integer, and a floating point number. And while we're not going to use this too much for now, this outer list is a 3-item list, and the second item is another list. So this is kind of alluding toward what we'll do when we start talking about data structures, and that is we have a structure and then we have another structure inside of it, and sometimes this can get quite complex. And we're doing this for a reason. This here has no reason, just to show you that it's possible that lists can be made up of lots of things, including other lists. And of course there is also the notion of the empty list. And like I said, I have had to be able to tell you about lists all along. We use them in for loops. we can put lots of things here. We can put file handle here, we can go through the file, we can put a string there, we can go through the characters in the string, and in a list. And the iteration variable then goes through the successive elements of the list, and that's why this prints out y 4, 3, 2, 1, and then the loop is done and it prints out blast off. So we've been using them, and we've been actually iterating through lists with for statements all along. So the for statement, has been something we use with lists, and when you just need to go iterate through the list and go through every item in order, the for is a great way to do that. So friend is our iteration variable, friends is our list variable, and so that says friend is going to successfully take on the value Joseph, Glenn, and Sally and print out, Happy New Year, Joseph, Glenn, and Sally. It runs 3 times, once for each of the values, and the iteration variable advances. Now, I do want to make it really clear that the choice of friends and friend singular and plural is arbitrary and capricious. It happens to be convenient and intuitive that the iteration variable is 1 and the list variable is more than 1. But Python has no idea about singular and plural. As a matter of fact, Python would care. It would be totally equivalent for Python to do the same thing, to have the list variable be z and the iteration variable be x. X will take on the successive values of these 3 things. Now, am I being nice to you by calling this list friends and this iteration variable friend? I am, but I also don't want it to confuse you if you're just a beginning developer. So, just like strings, we can sort of look within lists. Part of the thing is when you put more than one thing in a data structure, you need to get them out. And so lists have positions, they maintain order, and so the first thing in the list is the sub-0 position, sub-1, sub-2. Just like strings, they're 0-based, just like European elevators, they're 0-based. So if we take a look and we say, oh, friend sub-1, that's how I read that. The little square brackets, when you take a variable here and you say friend sub-1. Remember, singular and plural don't matter. Friend sub-1 means Glenn, because this is the 0 and that's the 1, and then Sally's the sub-2, and so that's what prints Glenn out in this particular thing. Now, lists are mutable. Mutable is another word for changeable. They can be changed, meaning that a list has 3 things. You can change the thing right in the middle if you want. To take a look at what's not mutable, strings are not mutable. So if I take a look at assigning banana into fruit, well, fruit sub-0 is a capital letter B. Could we imagine for the moment that we could change fruit sub-0 to lowercase b? Well, the syntax would be how you would do it if you could do it, but it turns out that strings are not mutable, meaning they're not changeable once you create them. And that's why when we do things like lowercase or uppercase, we take a look at the fruit and we say, give me a lowercase copy of that, and then we take the return value from this and we store that in x, and that's how x becomes a lowercase banana. But fruit is still the original one, so fruit has not changed. Compare and contrast that with a list, though. Here we have a 5-item list, 2, 14, 26, 41, and we're going to do the sub-2 position, and the sub-2 is 0, 1, 2, so that's that one right there, and we're going to assign a 28 into it. So that 28 is going in here, going to wipe that out and put 28 in. So we can do item assignment in lists by putting a bracket syntax on the left-hand side to say, don't just put it in the variable, put it in this position within the variable. So that's what that's doing, and when you print that out to 28, everything else is unchanged, meaning the whole list is there. There could be 1,000 items in the list, and then you're changing the second one. We have a function called len. We've been using this len function all along to take a look at how long strings are. It counts the number of characters in the string, so that's a 9-character string. If we have items in a list, len tells us how many items there are. It's not like how many characters there are, it's the number of things. And each thing doesn't have to be a number. It could be a number, a string, or even another list. And len is the way to say, hey, how many things are in there? There's a function that returns a list of numbers, and we use it, as we'll see in a second, to construct specialized loops to go through lists. So let's take a look at this range function just for a minute. So range takes as its parameter the number of numbers that you want returned. So I'd like a 4-item list with the numbers 0 up to but not including 4. And so it just turns out that that is really useful for constructing for loops that are counted for loops that go to 0 to the 1 to the 2, as compared to the the definite loops that go each way, go through each one. And so it's a common thing to say, okay, we know how many things are in this list. There are 3 friends. And if I put combine range and len, so I take len friends, which is 3, and then I take range sub 3, I get 0, 1, and 2. And so the interesting thing is this 0 corresponds to the first one, 1 corresponds to the second one, and 2 corresponds to the third one. Okay? And so we'll use this to construct loops, especially when we need to go through an array and remember what position we're at. And so here's just an example of 2 different loops. This is a for loop that's just going to go through whatever's in this list. So friend is just going to take on the successive values, and so it's going to print out these 3 things just as you would expect. And if you don't need to, while you're going through the loop, know the position, your relative position from the top in the loop, that's okay. But sometimes you want a little more sophisticated loop, and instead you want to be able to loop through where you know the position. And so what we do instead is, instead of looping through the list itself, we do range len friends, which gives us 0, 1, 2. And then I takes on the successive values 0, 1, and then 2. So this loop is going to run 4 times, and I is 0 the first time. And we might even just look up the value inside that sub-0 value, so we get Joseph the first time, so prints out Happy New Year Joseph, goes, and I becomes 1 now, and so it gives us Glenn, and that prints out, and away you go. So if you look at these 2 loops, they really do the exact same thing. The only difference is this we allowed the for to find its way with the iteration variable through, and here we created our own I variable that went through the positions, and they're dense, there's no gaps in here, so it's 0 through 2 that it goes through. So these 2 are equivalent. There will be times when you'll want to use one in the other. I tend to prefer the first one because it's prettier as long as it works for me. So that gets us started with loops. We'll be back in just a bit. Okay, so we've taken a look at loops, and now we're going to just take a bit of a look at some of the operations that you can do with loops. Python has this, as we'll soon learn, object-oriented approach to its operators, and the plus can add strings and it can add numbers. It can add floating point numbers, integer numbers, strings, etc. And so the plus similarly works this way with lists. The plus looks to its left and looks to its right and says, what am I adding? And in the case that I'm adding the list 1, 2, 3 and the list 4, 5, 6, it concatenates them together. In this way, it sort of functions like a string, and so we get 1, 2, 3, 4, 5, 6. It's just concatenate this list to another list. And it doesn't change A or B, just like in any kind of assignment statement. Calculations on the right side don't change the variables, and they produce a new variable and then assign that into C. You can also use list slicing, and it's easy to remember. If you remember how strings work, list works exactly the same way. So it's, of course it's a little tricky. The first number is the starting position. They start at 0. So 1 is right there. So it's the 0 position, the 1 position. Start at 1, right? But go up to, but not including 3. There's 1, 2, 3. So this goes up to, but not including 3. And that's why we get 4112 out of that. So up to, but not including. I'll just say that over and over and over again. If we do, you can leave the first part out. You can leave the first part out here, and you can say, oh, up to, but not including 4. So that starts at the beginning, goes up to, but not including 4. And so that's how we get that piece right there. We can say, start at the position 3, 0, 1, 2, 3. Start at position 3 and go to the end. Now the fact that the number 3 is in here is sort of irrelevant. 3 to the end is those 3 numbers. And then you can do the whole list with slicing as well. Again, these pretty much are the exact same examples I used when I was doing strings. They're pretty much the same. There's a number of different methods, and you can look up all the documentation in list. I often just use the dir command to remind myself of them. Append will look at. Count looks for certain values in the list. Extend adds things to the end of the list. Index looks things up in the list. Insert allows the list to sort of be expanded in the middle. Pop pulls things off the top. Remove removes an item in the middle. Reverse flips the order of them, and sort puts them sorted order based on the values. So let's look at a couple of these. So if we build a list from scratch, we have a way to ask for an empty list. There are a couple of different ways to ask for an empty list. We could use just two square brackets next to each other, but this is a form we call the constructor form, where we say, hey Python, make a list. In this case, the word list is like a reserved word to Python. It's really a reserved class, but say list parentheses says make me an empty list, and then assign that list into stuff. So stuff is now it's a list object, it's of type list, but it has nothing in it. And then we can call the append method, stuff.append, and stick book in. And then we say, oh, and that knows how long, the stuff knows how long it is, where the end is, and how to add something to it, and then add a 99 to it, and we print it out. We got book and 99, reminding ourselves that lists, while they're often the same types of variables, same types of values in the various positions in the list, it doesn't always have to be that way. Then we say, oh, we'll stuff.append cookie. You can keep on going, and then we end up with three things and the cookie. We have an in operator. It works pretty much like the in operator in a string. Is 9 in my list? And that's pretty simple, and the answer, of course, is yes, 9 is in my list. Is 15 in my list? Looking through, no, it's not. 15 is not in my list. And then there's the not in operator. You can think of that as kind of like one operator. Is 20 not in the list? And the answer, since it's not there, is true. And so that's a way to just, it's kind of like starts with or in for strings, same kind of stuff. Lists are in order, and they're sortable. And so this is something that we take good advantage of. A lot of what computers want to do is sort stuff. Look all these things up, append them, and then get them sorted. And so there is this method inside of list that's just the sort method. So here we put three values in 0, 1, 2 position, 0, 1, and 2, Joseph, Glenn, and Sally. And then we tell the list to sort itself, and then we print it out. Now, this is actually sorted the list in place, which is different than upper and lower, because if you remember, strings are not mutable, but lists are mutable. And so you say, hey, just sort yourself. Okay, and so just sort yourself, and then it sorts it, and then it's in alphabetical order, Glenn, Joseph, and Sally. I happen to be clever. I only put strings in there, and I put my uppercase and lowercase in a very consistent pattern, but the list is changed. And if I look at list sub 1, that is the second item, which is Joseph, that prints out right down there. There's a whole bunch of built-in functions to help manipulate lists. The other things I was showing was sort is a method that's part of lists, but there are other functions that take lists as their arguments. We already talked about the len function, tells you how many items there are. There is pretty obvious max, it says go through and find the largest. Min, go through and find the smallest. Sum goes through, adds them all up. And we can say let's do average by taking the sum of all of them and dividing it by the length. And you might think to yourself, oh wow, I wish we'd have known this a few chapters back when we were having to write all those loops to do max, min, sum, largest, smallest, etc. You can kind of think in your mind that inside each one of these functions is a loop that does pretty much what you did in those chapters. And part of the reason we did that back then, even though these things were here, was they're kind of easy loops to understand. And so those are there. And basically there allows two different ways of building loops to do the maximum minimum. Now it's not necessarily all that much easier to to do something using these, because you either can do them the old way or you can make a list and then use these functions. So let's take a look, and I'll just say that these two bits of code are doing the exact same thing. And what they are is they're implementing a program that's going to repeatedly ask for numbers until we type the word done, and then it's going to compute the average and tell us what they are. And so using sort of the stuff from the loop chapter, we start with a total variable and a count variable, set them to 0, and then we read a number, we check for done to break out, but then we convert it to a floating point value. And then we say total equals total plus value and count equals count plus 1. And so this is going to run over and over and over again, however many times we're going to do this. And then it's going to pop out, and when it's done, it's going to have this value of total. The running total will become the overall total divided by count, and it'll print the average out. Okay? And so that's kind of how we would have done this before we knew how to do this with lists. Now, let's take a look at the other one. In the other one, we say, let's make an empty list. Remember, this is that constructor syntax that says to Python, make me an empty list, and assign the empty list. It has nothing in it, right? But it is a list, has nothing in it, into the variable num list. Now we're going to write another loop. This part here is the same, these 3 lines. Read the number, if it's done, quit, and convert it to value. But instead of doing the actual calculation right now, what we're going to do is just append it to the list. So the list will start out empty, then the 3 will be in the list, then the 9 will be in the list, then the 5 will be in the list. So we're appending, each time through the loop, we're appending into the list. So we're just growing the list every time I read a value, instead of actually computing something with the value that we've got. So in either case we get value, and in one case we append it to the list. And then finally it finishes, the break happens, and then we just say, oh, hey, Python, sum up everything in the list, add these 3 numbers together, and then divide it by the length of all those things, and you'll have the average. And so these 2 things give us exactly the same output. Now there is one difference. If there was like 1 million or 1 billion numbers, they actually have to all be stored in the memory simultaneously, whereas here it's actually doing the calculation of the billion numbers and not using up so much memory. For most of the things that you're going to be doing, the difference in memory, there is a difference in memory. This one here uses more memory, but I can't draw very well. More memory. It uses more memory, but it doesn't really matter by the time it's all said and done. And so for you, the difference between these things is not all that significant, but it's important to understand that they're just 2 techniques to accomplish the same thing with lists. So now we're going to wrap up and talk a little bit about how strings and lists are related. They're sort of related in that they both have zero-based things, and we use the square bracket operator to do various things. But there's a lot of situations where we're looking at our data and we're combining the use of lists and strings. So let me show you the first thing, probably the coolest thing. We're going to use it a lot the rest of the class, and that is the split function. So let's take a string. We've got ABC here. It's with 3 words. What we're interested in, the fact, is that there's spaces in this word. And what split does is says, you know, I'm going to look through this thing, I'm going to find this, and I'm going to break this into pieces, and I'm going to return you a list of the separate individual pieces. So look for blanks and break it in pieces and give me back the pieces. So I'll print these out, and now you see that it's a list with 3 items, with 3 words. The spaces are gone, but it's given it to us. So it's like, split this into words, please, and give me the individual words, and give me a list of individual words rather than a big long string with spaces in the middle of it. And that is a quick way to go from a line, and it's really common. A lot of things we're going like, go get the second thing or the third thing or whatever. So the split's really nice because then you can just grab stuff. And so you say, oh, how many things did I get? Well, I got 3. The len function tells us that. And I can print the first word I got, which is with the sub-0, and that'll be like with, will be the first word because that's the sub-0 position. So I read something, I split it, I can say there's 3 things, and I can look at stuff, the first word basically, without really knowing much. Now if you remember earlier, and we'll see this, we used find and slicing to do a similar kind of thing, but people tend to prefer the split. And you can, you know, oops, go back. You can also then loop through them, so you can split these things into stuff as a word, and then go through with W, and then it's going to go through. W is going to take the successive with 3 words, and so you can make a loop by reading some data, splitting it, then writing a for loop, and then it's effectively going through the words in that line of data. And so that's a really powerful concept that we'll use in a lot of the programs that we're going to write. Just a couple of bits about this and how it works. Split with no parameters here, it looks for spaces, but it also treats a bunch of spaces as a single space. And so it's pretty smart about that. And so even though this has a lot of spaces between lot and of, you only see lot of, all the spaces are gone. It does something special about spaces. It's really white space, so tabs or new lines or other characters would also qualify in split, basically. Now, you don't always have to split based on spaces, and a lot of data that you're going to run into, you're going to want to split on something else. And so here's some data that looks like we're using colons to separate the first, second, and third piece. Now if you just call split, split's looking for spaces. And so split gives you back a list of the things broken apart with spaces, but there's not a single space in that line. And so we get a list, see it's a list, but there's only one item, and the semicolons are sitting there. Split doesn't go like, whoa, this looks like it should be semicolons. You know, split's job is to use spaces and split the string based on spaces. Okay? But given that this is something we like to do, you can tell split what character you'd actually like to split on. Now, it's not quite as clever when splitting on something other than spaces. It doesn't understand that, you know, if there's a bunch of semicolons in a row, it still thinks of those as splitting points to split. But in this particular case, where there's no spaces, you know, and it's going to split that. So it says split this based on the semicolon, based instead of being based on the space. And so if you take a look at what comes out of this, we split on semicolon. Now we have a 3-item list, and we get first, second, and third. And a lot of your data comes out of some logging system or some router status updates. Who knows what you're looking at? But the delimiter is often something other than space, and you can do that with split. So this is a useful thing when parsing things like our email address, right? We wanted to get things like the email address, this second piece, off of the line. And so we can use split to take advantage of this. And so here's a little loop that's just going to print out not the email addresses, but instead the day of the week. We're going to print the day of the week out for all these things. How do we do that? Well, we can observe really quickly that if we split based on spaces, it's the 0, 1, 2. It's the 2 position. So we can quickly write a bit of code that, you know, opens the file, then loops through the lines. We do this all the time now. Strip takes off the end of the new lines. We can check to see if it starts with from space, right? From space is our key, so we're ignoring all of the lines that don't start with from space. But then we find a line that starts with from space, and we split it, and then we just print out the second word. And so we get the second word of the lines that start with from, and that's how this thing works. Now, sometimes we want to dig into deeper, and we will take something, split it, and then split another piece of it again with a different delimiter. And so let's just say that the thing that we want to achieve is getting the part after the @ sign for email addresses. And we did this with, again, find and pose and stuff like that, but you can use split to do this as well. So the first thing we're going to do is we're going to take this line, we're going to split it based on spaces, right? Chop, 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 chop. And the fact that there's an extra space there doesn't matter. Split happily just like zooms through that. And then words sub 1, 0, 1, 2. Word sub 1 is this email address. So we'll put that in a variable called email. And so email will be a string that's just this. So in 2 lines, we've pulled out this second address into a variable. Then what we're going to do is we're going to re-split that. We're going to take this string we've got and split it based on @ sign because we know it's an email address. So we get a new set of pieces. The first part is the person's name, and the second part is the host name that their email is hosted on. And then what we can do then is we just happen to know that this is the 0 item and this is the 1 item, so we can get at that. So the interesting thing of going here, if you think back to how we did this before with find and pose and all that stuff, it's really a lot cleaner. And we don't, for me, I can look at this after you understand it, and it's easy for me to understand that it's correct. Whereas that pose stuff, you got to add one and start the second find after. Just remember that. And this is a lot cleaner way. And this is a more typical way of pulling this kind of information out of a line. So in this chapter, we've talked about lists. We've talked about the concept of collections. That's our first data structure. We're not just doing algorithms. We kind of know algorithms now. But now we're going to do data structures. And this chapter and the next 2 chapters are our foundational data structures. And then we'll, like everything, we'll make more complex data structures by composing those data structures together. We've looked at how strings and lists connect together and how split works. And these are all really powerful tools that we're going to use going forward. Now we're going to take a look at how we would write some code to do some parsing, read some data. As a matter of fact, we're going to read through our famous mailbox data, look for lines that begin with from space, and extract the third word. As a matter of fact, we already have some of this code already written. We're going to debug it. We're going to look at code and we're going to debug it. And so here we go. Here we have it, and it's a pretty basic program. It opens a file, loops through the file, throws away the white space, splits it into words, and checks to see if the 0th word, the first word, is from, and if it's not, we skip and read the next line. And otherwise, if we find a line that starts with from space, then we print the 3rd word, which is word sub 2. Okay, so this is what we've got, and we carefully saved this file into the same folder that we've got, ex08. And so let's go ahead, cd desktop python for everybody, ex_08. And so this is some files. We got our day of the week Python and our inbox short, so that's sitting there. Okay. And so let's run this program. This is the program that we've got right here, Python 3 dow.py, and it doesn't work. Now, by now you've seen a few tracebacks, and there you go. So, you know, when you look at a traceback, you think to yourself, well, I made a mistake, and you've gotten pretty good at looking at that line. So there you are. You're like, this is the line. There must be something wrong on this line. And you want to change it. But that line's not actually the problem in this particular thing. And so you got to be careful sometimes. And one of the things that you didn't notice in this one right away is that it actually worked. It printed the first line out. So if we take a look at our data set, it found the line started with from space, it split it, and printed out the 3rd word. And it blew up later. And so part of the problem is that we don't know what it was doing when it blew up. And so the first thing I'd like to do in this kind of a situation is find the line and make sure there's a print statement right before it. And so I'm going to print words colon and then comma WDS. I want to print right before the line that blows up, so that I know really when this finally does blow up what was going on in that line. So I'm going to run it again. And oop, did I forget to save it? No, I forgot to save it. Look at that. See the little blue dot? Forgot to save it. So now we see a whole bunch of output, and we see that it's actually doing a whole lot of work before it's blowing up. And so you see that it prints the words out from that first line and prints out Saturday, which is exactly what we expect. It's the 3rd word in the line. And then reads a whole bunch of stuff. And it's actually, what's doing now is ignoring. Let me just put something here. I'm going to say print ignore. So I can keep track of when these lines are being ignored. So let's run it again and have the word ignore pop up. Right? And so it's doing a lot of ignoring. It finds these words, prints out Saturday, reads this line and ignores it, reads this line and ignores it, reads this line and ignores it. So a lot of stuff's going on here that you might not realize. And so we have to take a look at what the problem is. And so it is now blowing up word sub 0, and now we can scroll down and we can look at exactly what happened right before the traceback. So we really now know exactly what happened before the traceback. And the interesting thing is that there is an empty string. I mean empty array. There's an array with 0 items. So I'm going to print the line out too. Print line colon. Now I haven't changed my program at all. I'm just trying to figure out what's going on here. So I'll save that and I'm going to run it. And we've got a lot of stuff and it's still working. It reads a line. It reads a line, splits it into words, and then prints out Saturday, which is the 3rd word on the line. Now here it reads a line, and this line is a blank line. And it has, because it's a blank line, the split returns no words, and that's what blows up. And the problem now is, oh wait a sec, list index out of range. So word sub 0 is not valid, which is the first word, when there are no words. So this is a statement that works most of the time. Now you might think, oh, I want to just put a try and except in there. Well, the right thing to do is to say to yourself, oh, wait a second. If I don't have enough words, if the length of the words is less than 1, continue. So basically it's going to come through here, it's going to split it, and if we don't have any words, meaning it's a blank line, then we're going to skip it. So let's run that. So now this ran all the way to the end. It did a lot of stuff, and it did not blow up specifically, didn't have a traceback. Another way to protect this would be to, we'll take this part out. This is called a guardian pattern. Right, guardian pattern, because this is dangerous. This could blow up, but it won't blow up if it makes it past here, and it won't come through there under the conditions that are causing it to blow up. Another way to do this might be to protect it as follows. To say, oh, wait a sec. If the line is a blank line, no continue. So now what we're going to do is we're going to skip blank lines. I even say this. Print skip blank. So if it's a blank, we're going to skip blank and keep going. This will skip blank lines. It'll come through here, and this will skip lines that don't have from. But because we're not processing blank lines, word sub 0 always works. So I can run this code, and it works again. So here we have a blank line, we skipped it. Here we have a blank line, we skipped it. Now here we had a non-blank line, so we parsed it, but then we ignored it. And then up here we'll find a from somewhere. Doo-doo-doo-doo-doo. Let's find a from. Here it comes. Oh, no, there's ignore, ignore. I got too much debug print. I can't find it. Here, I'll just hunt for from with find. Okay, so there we go. There's from, and we print the thing out. So we're getting a lot of extra stuff. So I'm gonna comment out some of these debugs, and I'm actually just going to get rid of this whole skipping of the blank line. I'm going to do it with the words. I'm going to go back to the guardian we had before. If the number of words that we got, len of words, is less than 1, continue. Okay, so now this is going to be a working program. Oops. I gotta take another print statement out. Gotta take another print statement out. We sort of know what we're doing here. Okay, so this looks like a pretty safe thing. This guardian is protecting this dangerous. I'll get rid of that one too. This is the words that are traced back, and nothing else in this thing changed from when we started except we've added this little guardian. Now the interesting thing is if it comes through here and prints word sub 2, what happens if somehow we find a line that has from as its first word and there's only one word on? This is going to blow up. So we can make our guardian a little stronger. And we can say, you know what? We're gonna skip this line if it doesn't have 3 words in it. So it has to have at least 3 words. And if we see less than 3 words, we're going to skip it. And that just makes the guardian a bit stronger. And so the program works safely, and you see these things where sometimes you want to check to see that your assumptions about the data are reasonable, and skip things where the data is not reasonable. Now so that's one guardian pattern. Let me show you a slightly different way to do this, and this is with an OR statement. So I'm going to take this code, copy that, and put it here with OR. Get rid of all this stuff. Well, this is the guardian in a compound statement. So what we're saying is if there are less than 3 words on the line, or if the first word is not from, continue. Now, we're doing this in order because the way it works is OR is true if either that's true or this is true, but if it knows that this is true, then it doesn't bother checking this. And the checking of this is what blows up, what causes the traceback. So if we flip this order, it would fail. If we do it in this order, it will work. So let's do this one right. It works. But if I get this backwards, it's going to check this before it checks this. And we're going to go back to failing again. So you got to get the order of these things right. The guardian comes before, in the OR, the guardian comes before. And if this is true, then it doesn't check this. This is called short circuit evaluation, where it knows that as long as this part's true, it doesn't evaluate this second part. And so now we have a guardian in a compound statement. You'll see this a lot. Sometimes if it's more complex, you do it in multiple statements, or you sort of fall through, check for sanity, and only run the code. So I hope that was useful to you, looking a little bit about how to debug, where you don't just start chopping on the line that had the problem. It's not always that line, because we never did change that line. Although we did change it a little bit at the end. We added this guardian here, but we also fixed it without it. Sometimes you add some print statements to figure out what's going on before you just start chopping on that line. So again, I hope this helps. Thanks. Hello and welcome to Chapter 9. Now we're going to talk about Python dictionaries. Python dictionaries are probably the thing that most programmers love the most about Python because they're very powerful. They're like a little in-memory database. It's the second of our kinds of collections and probably the best collection. To review what a collection is, it is a situation where we are going to have a variable, like a list or a dictionary, that we can put multiple pieces of information in rather than a single piece of information. And of course, prior to collections, we would put something into X and then we would put something else into X and it would be overwritten. And now with lists, we can append things onto the end. And so if we compare lists and dictionaries, the list is sort of the organized version of the collections. Everything stays in order. You add something, it always adds to the end. You take something, it sort of compacts itself. It's 0 through the n-1, where n is the number of items. And so it's very organized, kind of like a Pringles, where the potato chips are nicely stacked. Dictionaries are messier. You can put things into dictionaries. There's no real sense of order in dictionaries. Everything has a key, so you sort of throw things in and they kind of mix around in there somehow, and you pull things out based on the key. It's like you sort of stick a label on it, where you say, okay, I'm going to take this thing and I'm going to put Chuck on it, and I'm going to take these sunglasses with the Chuck label, and I'm going to throw it into the dictionary, and I'm like, hey, give me back Chuck. I'm like, oh, here's your sunglasses, because you mark everything. This is like the key. This is the value. I took a pair of sunglasses and I threw it in. So it's kind of like a purse, or it's a sort of like a mess. And so the idea is you have these labels that you put on everything that you're going to throw in. Like I'm going to put, hope it won't stick to my keys. What else do I got here? I'm going to stick a label on my pen, a Chuck label, and I'm going to store a pen in my dictionary with the Chuck label. And so it's like having a purse or a bag or a backpack where you have things labeled, and you can throw things in and label them, and you can shout into your bag and say, give me the calculator, or give me the candy, or whatever it is that you have labeled them. You have to come up with the labels, and then you can use the labels to get things back out. And like I said, they're probably the most powerful thing, and they're basically this concept that's generally referred to as associative arrays, which means they're like lists, but they have these keys. And so the associative means the association between a key and a value. Whereas in a list, there's a position in a value, and the position is less powerful and less flexible. Most modern programming languages have this notion of associative arrays. If they don't, they're sort of unpopular, because once you get using them, you're like, whoa, they're so powerful. If you ever find yourself in a language that doesn't have them, you'll you'll freak out. They have different names like property maps or hash maps or property bags, depending on the language you're using, but they all are the same thing. They're key value pairs. So the idea of a dictionary is that, or the idea of any collection is putting more than one thing in, and then the difference is that you have ways of indexing it. So this basically line says let's make ourselves a dictionary just like we constructed an empty list, and I want to store 12 into this dictionary and I want to label it money. And so on the left hand side, when we use this money, that's the label that we're going to give it. And so 12 is being placed in the dictionary. That's like taking the 12, throwing it in the dictionary with a label of money. 3 is going in with a label of candy, and 75 is going in with tissues. And we say, what's in there? And there's no order to it. And sometimes the order can even change inside of a dictionary. Although there are more advanced versions of dictionaries that maintain some kind of order, but for now let's just not worry about the ordering of them. If we say what's in there, you say, oh, there's 3 things in there. There is 12, 75, and 3, and stored under the keys money, tissues, and candy, respectively. We can ask, using the index operator, what is per sub candy? And that's like saying, hey, give me back candy, and out comes the number 3, which is that. We can update stuff. So we can say, go grab the candy version, add 2 to it, make 5, and then store that back into candy. And so now we see that candy has been set up to be 5. And and so if you look at the difference between lists and dictionaries, they both can have new items added to them. We haven't talked a lot about deleting, but items can be deleted from them. The difference is the indexing mechanism, how we look things up, how we store things, and how we look things up. So we make an empty list, we make an empty dictionary. We add 21 to the end, and we add 183 to the end, and we ask it and says, oh, position 0 is 21 and position 1 is 183. We don't see the positions when we print it out because it's sort of implicit. Here we're going to mark 21 with age and stick it in, and mark 182 with course and stick it in, and then we're going to print it out, and there we got course and age mapped. And we can add a 23 and stick it back in age, and that overwrites. So the 21 becomes the 23. We can do the same thing in a list, except we say lists of 0, because in lists the indexing is position, and so this 21 becomes 23. And again, you just look at them and you can think of each of these as pretty much doing roughly the same thing except the indexing mechanism. The values are the same, but the keys are different. So in lists the keys are always the position, and you don't get to assign those other than the fact that the order in which you put them in implicitly assigns a position. And in dictionaries the key is a string. You can actually use other things. I use strings a lot in this lecture, but that's just to kind of keep things simple until you get good at it. You can actually use numbers as the dictionary index, the dictionary keys if you want. But the values are things you put in and manage in those dictionaries. So we can, just like lists, we have dictionary literals. And what's nice about dictionary literals is that they use the exact same syntax as the printout. And so it starts with a curly brace, ends with a curly brace, and then has a series of key colon value, key colon value, key colon value. And this is sort of the associative array bit. We are associating 1 with the key Chuck. We are associating 42 with the key Fred. We're associating Jan and 100. Then we print it out, it kind of looks exactly the same. And so the print statements in Python are nice in that you ask what's in a thing, you show the stuff, and it shows you in the syntax that if you type that into Python, that would be how you do a constant. And if you just say empty array, you see me also do DICT. This is constructor where you say make a new empty dictionary. This is an empty dictionary constant. These two things are pretty much the exact same thing. This is a shortcut to doing this. The empty curly braces is a shortcut to do the construction. So up next we're going to talk about sort of one of the really common applications of dictionaries, and that is counting. So now we're going to talk to you about one of the common applications of dictionaries, and that is making histograms. It's counting the frequency of things. And so if you think of a histogram as, it's a little graph, and there is, how many A's, how many B's, and how many C's, and there's a histogram that says, oh, there's this many of that and this many of that, and these are like buckets, these are frequencies, and this is how many times it happens. So a histogram. But we're going to do this thing where we're going to count people's names, and we're going to kind of count how many that we see. But the interesting thing that we're going to solve, just like many of the things in the computer, is we can't just sort of look at the data. We got to look at the data iteratively, one piece of data at a time. So I'm going to give you a little problem. Okay, I'm going to show you a series of names one at a time, and I want you to count for each name, make a little bucket, and then keep counting how many things for each of the different names. Okay, you'll notice that you have to start with one and then you move across. So just watch this and tell me what's the most common name of the set of names I'm about to show you, and how many do we see? So what was the most common name and how many times did you see it? That's the question. Now, here comes the reveal. So for humans, it's so much easier for you to just look at this and you think, how did my brain look at that? And you're like, okay, what is pretty common? Oh, maybe Chen is common. Oh, Chen, no. Maybe Zhen is common. 1, 2, 3, 4. Yeah, anybody else have? Marquard's got 3, C7. And so you'll notice how our minds, without computers, we just sort of like bounce, branch and bound. We have hypotheses, and then we decide, yep, it's Zhen. That's it, and there's 4 of them. Now, how did your brain think about this as we were going through them one at a time? Well, my guess is if you really had to do this a lot, you would make a little picture like this. And then what you would do is if you saw a new name, XYZ, you'd add it to the list and give it a tick mark of 1. And then if you saw like C7 again, you'd give that a tick mark. And if you saw XYZ again, you'd make a tick mark. And then you'd keep adding to these tick marks, right? And that's how you would do it. And you wouldn't, like many of the things we do in a loop, you wouldn't really know what the most common was until the end. And then you'd sort of take a look at these numbers and you say, okay, that's the most common number, and then you'd be done. But you have to watch them one at a time. You can't just bounce around. And so that's how we're going to use dictionaries to achieve that. Again, instinctively as humans, we just look at the stuff. But if you had a million things, you probably want to write a Python program and use dictionaries. And so this is the idea, and there's 2 basic things that happen. One is the first time you see a name, you got to say, is this name there already? If it's there already, you really just want to add 1 to it, right? That's the adding of a tick. Or you want to see for the first time, blah, 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 and give it a 1. And so you can use the name as the key. And then 1 is the value. And then first time you see Chen, you stick 1 in there. And so at this point, inside the dictionary, sort of dynamically adding, as soon as it sees a new name, it adds another slot in here. But then if you see the same name again, like Chen again, then you end up with a 1, add 1 to it, and so it's 2. And so at that point, Chen is 2. And so you can see how you can both extend the dictionary by encountering a new name, or adding when you see a name that you've already seen before. The problem with dictionaries is, like everything in Python, there are rules about what you can and can't do. And one of the, I think, kind of frustrating things about dictionaries is that you can't just look for a key that doesn't exist. So this is a fresh, brand new dictionary. We do a constructor there, and we print out sub C7, and boom, it blows up. And that's bad. But we can solve this by the in operator. The in operator we've used in the for loops. We've used it in lists. We've used it in strings. So that is a question. It's saying, is C7 in CCC? Well, this is this empty one, and so it is, no, it is not. C7 is not in CCC. And so using this in operator, we can avoid the traceback. We can say, if it's not there, put it in. If it is there, add 1 to it. And that leads us to this bit of code. Okay, and that is the kind of code that we're going to build a histogram. This is going to histogram code, okay? And so this is going to have name as our iterator, names. Sorry, I made them singular and plural. That's nice, but so name is going to be csev chen, csev gen. Now normally we'll be reading this from a file, but for now we'll keep it easy. We're going to go through this. And we're going to have counts as our dictionary. So that starts out empty, and we're going to do a simple if-then else every time through the loop. If the name we're looking at is not in the dictionary already, is the key, then set it to be 1. If it's not, go get the old value, count subname, and then add 1 to it and stick it back in. So this line right here is new, adding a new thing, and this line right here is adding some things to existing things. And you do this long enough, you start with an empty one, and you do this long enough, at the very end, it will print out the histogram that you're looking for, the histogram you're looking for. And so you say, oh, we've seen csev twice, gen once, and chen twice. And so that's the idea. And so this can run 1,000,000 times if you want. Now, this notion of checking to see if a key exists and doing one thing if it doesn't exist and doing another thing if it does exist is such a common practice that the dictionary object has this method called get that collapses these 4 lines into 1 line. And so the idea is you're going to do one thing if it's in there and you're going to retrieve the current thing. Otherwise, you're going to pick a default value. In this case, we'll pick 0. This is like the default, right? Meaning what is not there. And if you say counts, now counts is a dictionary, .get, that's like string.upper, that's a method. You give it a key and then a default. And if the key exists, you get back what's in the key. If the key doesn't exist, you get the default. Okay? So, and with no traceback, this works. So the best way to think about this is those 4 lines are equal to that 1 line, because X is either going to be whatever was in there before if it exists, or it's going to be 0. Now, the nice thing about 0 is the next thing we're going to do is we're going to add 1 to it, so that's going to get us to 1. So collapsing that loop that we saw before, we can make it just a 1-line loop. And this will become an idiom. This will become something that you will get used to and you will use over and over and over again. And after a while, right now you're looking at it, boy, that's a lot of syntax and semicolons and whatever. After a while, you just type this and not even think about it. It's an idiom. It's basically included in this idiom is how to both create new entries in dictionaries and update existing entries by adding 1 to them. So everything else in this is the same. Name is going to go through these 5 values, and we're going to say count subname equals counts.get name, comma 0 plus 1. And so if, for example, this already has a 1 in it, then this is going to be 1 plus 1 becomes 2. If it's not, it's going to be 0 plus 1 equals 2. And so this is the idea of if new, set it to 1, not 0, set it to 1. Because the first time you see something, the count should be 1, not 0. So that's why we make this default. Now the get can be used for anything. It just so happens that 0 is a common default because it's really common that we're using this to basically make a histogram, right? Little histogram of A, B, C, right? And so we need to make a D, but then the histogram has to start at 1. So that's basically the simplified counting with get. And you know, there's a lot of things that we're going to do inside of Python that do have to do with frequencies and how many times certain things happened, and this pattern is a really good pattern to absolutely know. So now what we're going to do is we're going to switch from just looping through strings, but instead loop through files. And it's going to take a little bit of work because we have to open the file, and we'll bring a lot of things together at this point. So here would be another task, and that is here's a bunch of text from the book, and you can just split this into words and count and find out what the most common word is and how many times it occurs. So go ahead and try to do this for a second. Feel free to pause. Actually, don't bother pausing. This is too hard. We should write a program for this. It's not easy. Humans don't like this. It makes you concentrate. And so here is a counting pattern where we're going to take a line, and then later we'll read this in a file. And so this is just an adaptation, improvement of the previous thing. So we're going to start with an empty dictionary. We're going to ask for a line of text and read it in. And then we're going to use split. So remember the list of words? Well, what we're going to get here is a list of words. We'll print it out and we'll run this counting. This is the little loop. For every word in whatever this was, we're going to do this idiom of either adding a new entry or adding one to an existing entry and then printing that out. So let's take a look at what we get there. So if we run this, we can give it some text, and I've got this will be all one line, and then it splits it into words, and you see that these words here are split, 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 split. I mean, that's strings and splits. Remember, strings and lists and split. And so now the counting is going to go through this list. The clown ran after the, and it's going to build a histogram. The clown, one clown, the up, these things are going to go up, right? That's this histogram. And then when it's all said and done, we end up with the histogram. And so counts is the dictionary that ends up with a histogram. And we can, by inspection, see, oh, the is the most common word. And there are 7 of those, right? So if we sort of take a look at this, we start out, we make a dictionary, we read in a line of text, the text goes in, and then we split that, and we print the words out. So these are the words, right? Then we have a for loop that's going to loop through all those things and then produce a dictionary. And when we print the dictionary out, that's what we're going to get. And the is 7. Okay? So that's one line of text. That's how you walk across the words in a line of text after you've split the line into separate words. So now we're going to look at ways that you can loop through dictionaries. We just produced a loop that can build a dictionary, but now we're going to look at a dictionary. And so we'll start with a very, very simple example, and then we'll work to a slightly more complex example. So here's a dictionary, just the constant. Chuck is 1, Fred's 42, and Jan's 100. And so we're going to use a definite loop with the for key and counts. Now it doesn't have to mean key, but key is a good name because these are keys and values. K, V, keys and values. I just mentally think of this as keys and values and keys and values. So this iteration variable is going to walk the keys. It's not going to walk the values. It's going to walk the keys. Chuck, Fred, Jan. Not necessarily in that particular order. As you see, it goes Jan, Chuck, Fred, because just because I typed it in this order, it's not like a list. It doesn't stay in that order. It might move around a little bit as we add data to it or as we set the data up. And so you can, in the loop, you can get the key, and so that's what prints out the Chuck, Jan, Chuck, Fred, but then you can also get the corresponding count for each one of these by just pulling it out of the array. Pulling it out of the dictionary, right? And so we can pull out the corresponding value, and so we print out Jan 100, Chuck 1, Fred 2, and that runs this loop 3 times. So if you just use the in and you give a dictionary here, remember all the different things we've been able to put there on the end of a for loop, and dictionary is another thing we can put on, and we get a list of keys. Now there's a couple of methods that allow us to get the keys, and so we have, we can say turn this into a list, and we get a list of the keys. So this is a dictionary, the same dictionary. We get a list of the keys. You can also get a list of the keys by using the keys method. So that's take this dictionary JJJ and give me all the keys, which gives me a list, which is kind of the same thing. And then we can ask for the values, and they give me just then the values extracted out of this dictionary. So that's nice. Now the one thing is that while I said you can't predict the order, if in 2 statements you ask for the keys and then the values, they at least come out in the same order, even though you can't necessarily predict the order that they come out. They come out in the same order. And then there is a third thing that we can do, and that is ask for the items. And we can say, give me the items. And that gives us a list. This is our first really kind of composite combined data structure where it is a list, a 3-item list, 0, 1, 2, and inside that there is what are called 2 tuples. Jan maps to 100, Chuck maps to 1, Fred maps to 42. Coming up next, we're going to have a whole chapter on that, and so just take a look at that for the moment, and we will come back to that in some detail later. This whole items idea that gives us back a list of key value pairs, because it's not just a list of keys or a list of values, it's actually a list of key value pairs, allows us to write in Python a very clever and elegant loop. What we can do is actually, this items gives us back, each item in the list has a key and a value, and we can actually take two iteration variables. For AA, comma, BBB, this is two iteration variables. And if you're coming from another programming language, this is super cool, and it's a Python-only feature. I never have seen another language that's capable of doing something this simple and that elegantly. So what this basically does is says, we're going to simultaneously advance these two iteration variables. So this is going to be the key and the value, the K and the V. Key and the value is going to be Chuck 1, then they're both going to advance. Fred, 42, Jan, 100. And so that means in this simple loop, if we just print them out, we're going to get the key value pairs, of course, in the order. And so it's sort of AAA and BBB simultaneously walk down these key value pairs. And so that's really pretty, and it makes for a very succinct loop. The syntax is a little sort of disquieting when you first see it, but it's a super elegant thing, and you just have to say items. If you don't say items, you just get the keys. If you say items, you get the key value pairs, and you have to have two iteration variables. If you don't have two iteration variables and use items, it'll complain and say, what are you doing? I'm giving you two things, and you don't have two variables to receive them. So two iteration variables and items are basically related. Now, we're going to take a look, and this is code that I showed you perhaps many weeks ago about, I said this is a little story about how to read a file and count all the words in the file. And now we're back to it. And at this point, you should understand every single character of this program, every single concept of the program. You should literally stare at this and look at it, code it, play with it until you absolutely understand it. So let's take a look. Again, I showed you this weeks ago. So we're going to ask for a file name. Then we're going to open the file name. Then we're going to make an empty dictionary. Again, this is all stuff you've done before. And then we're going to have an iteration variable that's going to go through the lines in the file. Right? So line is going to go line, line, line. Then we are going to split that line, each line into words. Chop, 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 chop. So that's words is the list of the words in one line. We're inside of a loop that's going to go through all the lines. And then what we're going to do is we're going to have the word iteration iterate through each word in the line. And then what we're going to do is take each word in the line, and we're going to do this histogram. Right? So this is going to run not only just for every line, but for every word in every line. So we have a nested loop for every line, then we split it, and then we go across the line. So it's almost like a typewriter where we go ding, ding, and that's what we're doing. Ding, ding, ding. So it's like the outer loop is going down, down, down the lines, and the inner loop is going across the words. And eventually we are going to see in this last line, every single word in the file. And we're going to do the counts get word plus one, which is our magic histogram making line that if you don't remember what that is, go back a couple of slides. I just talked about it. At this point in the code, and it's important to be able to draw these lines, at this point in the code, you have the histogram, and it's in the variable counts. Now, we want to find the largest one. Now, we have written loops that can find the largest in a list, but now we want to find the largest value in the key value pairs of a dictionary. So we're going to start with we're going to know what the largest count is, and the largest word has that count, and we're going to set them both to none, because we're going to prime our loop. We have to prime our loop, and we're going to say to none. And so then we're going to write one of these cool things that says for word, comma, count. So word and count are going to go through the key value pairs, because we've got items here. So it's going to go through the key value pairs, loop through each key value, whatever it was. There could be a million words in here. We're going to go through every one. And what we're going to do is we're going to make sure that big count is the current largest count we've seen so far. And if it's none, well, then we haven't seen anything. Or the count we just read is greater than the big count so far. We are going to jump in, and this is sort of like, oh, this is a new personal best count for this particular data set. And so we're going to remember the word in big word, and we're going to remember the count in big count. So this is just a max loop. It's a maximum loop with the extra thing that we're recording in addition to what count is the largest, what the word that was associated with that count, recording it. So again, this is a starting part of the loop. We're going to do some work, and then when we exit the bottom of this, big word is going to be the word that is the most common, and big count is the number of times. And so if we run a file, we say, oh, in that file, 2 is the most common word, and it's 16 times. If we run the clown file, well, the is the most common word in 7. And so this now is and this could have a very large file and give you the most common word. And so that is sort of a really good application of dictionaries. So dictionaries are the most powerful, well, they're the most powerful collection we've seen so far. It is good to see both lists and dictionaries to understand what collections are. They are things inside of Python that can handle more than one item inside of it, and we'll learn about another collection about tuples in a second. Just understand the get method, because that leads to very compact code. Understanding there are various ways to iterate through dictionaries, and so we've learned a lot. But in the next section we will learn even more and put these together and do some sorting and do some other stuff and really start to see the real power of dictionaries.